Hello everyone, welcome back to my channel. Today we are continue with the chapter applications of the integrals. In this video we will continue with the questions of the exercise 10a which is related to the parabola. Now let us start with the question. Question is, find the area of the region which is enclosed by the parabola. Y square will be equals to 4ax and the chord y will be equals to mx. In this question we have given that the equation of the parabola which will be equals to y square will be equals to 4ax. From this equation it is clear that the parabola is along x axis. So firstly we will draw the parabola which is along the x axis. And it is given that the chord is y will be equals to mx. Now we have to draw the chord which is this line. Y will be equals to mx and this is the parabola. Y will be equals to 4ax. We have find the area of a region which is enclosed by the parabola and the chord, that means this area. So here we write that the chord is y will be equals to mx, which meets in the equation number 1, that means which meets the parabola. Now if we will put this value of y in equation number 1, then we get m square x square will be equals to 4ax. That means if we will take it in this side, then we get m square x square minus of 4ax which will be equals to 0. Now if we will take x common, then we get x into m square x minus of 4a which will be equals to 0. From this equation x will become 0 and m square x minus 4a will be equals to 0. From this x will become 4a upon m square. So therefore if we will put the value of x will be equals to 0 in this equation, then we get y will be equals to 0, and if we will put x will be equals to 4a upon m square in this equation, then we get y will be equals to 4ax upon 4am upon m square. Square and m get cancelled out and we get y will be equals to 4a upon m. That means y will become 0 and 4a upon m, and from this x will become 0 and 4a upon m square. So this is the value of x and y, where O is the origin having the point 0, 0, that means the vertex, and this is the point A. x0 and y0 be the points of the region O, and the point of intersection point A will become 4a upon m square and 4a upon m. Now area bounded by the curve 1 and above the x-axis, ordinate x will be equals to 0 and x will be equals to 4a upon m square. That means we have to take the limit 0 to 4a upon m square. That means we get the integral 0 to 4a upon m square y dx. Now we know that this is given y square will be equals to 4ax. If from this equation we will find the value of y, it will become y will be equals to root of 2ax. So it will become root of 4ax. From this y will become 2 root of a root of x, and if we will put this value here, then we get the integral 0 to 4a upon m square 2 root of a root of x dx, and this is a constant term, so we will take it outside. That means 2 root of a. Integral 0 to 4a upon m square root of x dx. That means we get 2 root of a, and if we will integrate this root of x, then we get x raised to the power 1 by 2 plus 1 upon 1 by 2 plus 1, limit from 0 to 4a upon m square. That means it will become 2 root of a, x raised to the power 3 upon 2 upon 3 upon 2, limit 0 to 4a upon m square. That means it will become 2 root of a into 2 upon 3, x raised to the power 3 by 2, limit 0 to 4a upon m square. That means it will become 4 root a upon 3. Now we have to put the upper limit, that means 4a upon m square raised to the power 3 by 2 minus of lower limit, that means 0. So it will become 4 root a upon 3 into 8 a raised to the power 3 by 2 upon m cube. That means it will become 32 upon 3 a square upon m cube. So this is the area which is bounded by the curve. Now we have to find the area which is bounded by the line y will be equals to mx, and which is along the x-axis, and for this ordinate x will be equals to 0 and x will be equals to 4a upon m square. That means we will take the limit 0 to 4a upon m square. That means we get the integral 0 to 4a upon m square y dx, and for the equation of a line y will be equals to mx, so we will put this value of y here. Then we get the integral 0 to 4a upon m square mx dx, and m is the constant, so we will take it outside. That means we get m integral of 0 to 4a upon m square x dx. Then we will integrate this term, then we get m x square upon 2 in limit 0 to 4a upon m square. That means now we have to put the upper limit, that means 4a upon m square. It will become 16a square upon m raised to the power 4, and to also take outside. Then minus of lower limit, it will become 0. So we get m upon 2 into 16a square upon m raised to the power 4. So it will become by cancellation 8 a square upon m cube square units. So this is the area which is bounded by the line. Now we have done with the area which is bounded by the curve and the line. Now for finding this region, area of this region, we have to subtract the area of line from the area of the curve. So therefore the required area will be equals to the area of curve, which will become 32 a square upon 3m cube minus of the area of line, that means 8 a square upon m cube. That means it will become 32 a square minus of 24 a square upon 3m cube. It will become 8 a square upon 3m square m cube square units. So this is the required area which is bounded by the curve and the line. Now in the next video we will start with the finding the area of the triangular region whose sides or the equation is given. If you like my video, then please like, subscribe and share my videos, and do not forget to press the bell icon for the notification of the more videos. Thanks for watching.